Now being recorded.
Yeah, fine. Okay, so hope you are doing. You are doing all the steps today. I'll be sending what your project would be. Okay, today in the group I'd be sending about it, and then I think so many are coming and leaving. So today is the manual attendance, so I'll have to take the screenshot. So make sure that after the attendance you leave. Okay, and then I think that Naga Vijay Harika, is that you had sent me the mail? So okay, fine. I'm wanting to note I'm whoever had sent the mail. That's it. Okay, so let's go with today's class. So we are almost in the end. So like machine learning is over. We are heading towards a deep learning. Like we don't go much deeper. Just you should know how it is. Like mainly like ANN, CNN and all. You will be knowing like you should get an idea of what it is. That is the whole point of this class and tomorrow's class also. So you could see the screen, right? So ANN. So ANN means artificial neural network. So most of you would have heard about this term, because I could see that many of you are from like in your college itself you are doing machine learning and stuffs, and that is why you have taken up, right? So you'd have learned about the machine learning. Most of you guys would have learned about the machine learning, and few of you wouldn't have learned, but then you would have learned about the neural system, right? When in your body, the neurons, like when we were in 10th or something, so we had the structure of the brain and everything, and you would have learned about the neurons, dendrites, all these things. I mean, anyone remembers all those stuffs?
Yes, ma'am.
Okay, ANN is actually an attempt to copy the human brain. Okay, what is our human brain? They just wanted to copy exactly how our human brain works. Okay, that is what they tried. Okay, so all in this full deep learning, that is what they are going to try. So now, like now in the deep learning, now we have voice over text. I mean, and also we can like if you want, if in, now this system is already available, like in Google you just say something, it will search and give. So like, so it had been possible because of this, all these deep learning systems, all these deep learning algorithms, they made it a possibility. So here like why, how it is that, because our human brain could see the text and read it aloud. Okay, similarly, if I want to write something, what I'm thinking or what I'm saying, I could write it. Okay, so these are all the functionalities of a human brain. So the brain actually give the signals or give the information to the passes to the stimulate to the my hands, and then I could write, or whatever I'm writing I could see and then I could say. So these are all the functionalities of the brain, and they actually wanted to do something exactly like the human brain. They wanted to have a clone of the human, because human are like they are highly I mean, you can't ever come towards that extent, but people try to that level so that they can come up with all these robots and so all these systems, no, everything is like an attempt for this. Everything is an attempt for like a human brain. Okay, so now go to the class. So neural networks are parallel computing devices. So what are parallel computing devices? Anyone? What are parallel computing devices? Okay, so parallel computing devices, like now parallel. Okay, so now parallel. So parallel in a normal thing is like we call it as parallel lines. Like what we call it as parallel lines. Like two lines will be like together. It's parallel lines or parallel roads. Okay, like they both are on the same phase. Okay, so now parallel computing devices means you have many systems working for the same thing or many processes. So now here, because the parallel computing device is only like you would have played this all these online games and everything, right? You would have played. You would be playing with someone else. I mean, with the computer. Now, if you are playing with playing chess, so that computer takes a move, right? So that is some other process, and you both of you are parallelly doing something. So the parallel computation is like so many processors or cores or computers working on a project or working together. Okay, that is the what parallel computing devices. So similarly, why how do you think this parallel computing devices came into existence? Because we take I in one hand I write, and one and in the ears I'll be having my headphone hearing the songs. So many things I'll be doing at the same time. Sometimes I'll be reading the text and messaging, as well as I'll be eating. So these are all the parallel things I'm doing. So they wanted the exact thing to happen over here in the neural networks also. That is why the whole concept, it's like evolved from the human beings. Okay, they have started realizing that human beings are like to get to the level of human beings, it's very hard, and they started trying one by one, and like it's never be they can't never, even though that robots and everything is there, they can't ever match the human brain. Okay, but still they try to the level maximum so that they could make the works easier. Okay, for us, like we have now dishwashers and so many stuffs we have, right? So all these things, like, and also the cleaning robots, all these are there so that our works are easier. So they try to, okay, clone or try to have a miniature, okay, of the human brains. Okay, so now this neural networks are parallel computing devices, which is basically an attempt to make a computer model of the brain. The main objective is to develop a system to perform various computational tasks faster than the traditional systems. These tasks include pattern recognition and classification, approximation, optimization, and data clustering. So the main objective of this is to make the things faster, the computational task faster. So now I could think things and I could decide it. Am I now if I had to recognize a pattern, I would think immediately and I could recognize. So, but same thing a computer should do. So, a lot of data would be given, and it would be trained such that it could recognize. So that is what happening over here. So next is an ANN is based on the collection of connected units or nodes called artificial neurons, which loosely model the neurons in biological brain. Each connection, like the synapses in the biological brain, can transmit signal to the neurons. An artificial neuron that receives a signal then processes in and can signal neurons connected to it. So this ANN is basically the artificial neurons, which you sorry, it's like artificial neurons, and it is like the similar to your biological brain, neurons in the biological brain. So that is a whole work of this artificial neuron in ANN is based on the biological neuron. So we will be comparing both the biological brain and the artificial thing. So this is what your biological neuron looks like. So here, when you take the biological neuron, you have this dendrites, then you have the soma cell body, then you have the axon, and then you have the synapses and connection with the other neurons. So this will be going on connecting over so many neurons. Okay, and that is how the information flows. So here this dendrites, these dendrites are the tree-like branches responsible for receiving the information from other neurons. So here this dendrites, here other neurons will be there, like how the here this are going to the other neurons over this side, here also other neurons will be there where this dendrites will be connected, and from that other neurons they will be getting the informations. Okay, so these are called, these dendrites are like receivers. Okay, So now, in other sense, we can say that they are like the ears of the neurons. Okay, from the other neurons, it will be receiving these dendrites, and then soma. It is a cell body of the neuron and is responsible for processing of information they have received from the dendrites. So this information is collected from the dendrites, and then in this cell body, the soma, it's where the processing of the information happens. Okay, so this is where all the process, okay, whatever I am receiving through my ear or eye or whatever it is, I will be processing with the help of the soma. So now here next is the axon. It is just like a cable through which neurons send the information. So now through which this is where the information is sent. And synapses, it is a connection between the axon and other neuron dendrites. So now this synapses connect with the other neuron dendrites. Okay, so here this flow of information goes through the synapses and it connects with the other neurons, other dendrites of the other neurons. Okay, so similarly, so many things will be connected throughout our brain. So this is a biological feature, okay, of a biological neuron system. So now here, when you compare with the biological neuron system and the artificial neuron system, this soma will be like a node, and these dendrites will be called as the input, and the synapse will be called as the weights or interconnections, and this axon will be like the output. Okay, so this is how they compare the biological neural network with the artificial neural network. So coming to the artificial neural network, so this is how it will be. So now here this inputs are, and then here you have this weights. You will be seeing a little more deeper about this weights and everything, activation function and all. So then this will be the output. So in simpler, you get the information, the inputs, and then here the all the processing happens like as in soma, and then you will get an output. Okay, so this here in the output, what you will be having is you will be having this x1 plus w1. Okay, so all this will be going through the summation, and then you will be having an activation function, and you will be having the output. So I'll say what is activation function and what is weights and bias now. So now here coming to this, here in this diagram, they haven't given the bias. So whenever there is a input is there, we will be having the weights and also a bias. Okay, so why do we have these both? We will see. So this is how actually it will be. Okay, so now inputs also will be there, weights also will be there, and bias also will be there. So now here the output will be actually having the weights into input and plus bias will be there. So now here if you see the same thing, the same equation actually you would have seen in the linear regression, where you have this y is equal to mx plus c. You people remember, right? Y is equal to mx plus c. So here this weight into input, all this will be like a summation, all these will be like mx. Okay, that is weight into input, and this plus c, this c is where the bias. Okay, this weight is m and x are the inputs, and this c is the bias. So it is similar to the linear equation, okay, and which we had, we studied previously, the very first class we studied all these things. Okay, so this is how the inputs, I mean, before getting the processing, we are adding some weights and bias. So this, why we adding the weight and the bias is for the effectiveness. Okay, so now the weight shows the effectiveness of a particular input. More the weight of the input, more it will have impact on the network. So we will be adding the weights according to the need of the network. Okay, according to what my output would be. So that effectiveness we will be adding the weight. So there is some procedures or adding the weight, how much weight will be given, all those things. Okay, so that you will be we'll be learning deeper into that later. Okay, I mean, when you search, I mean, when you google it, you'll be getting all those details. So now bias. So on the other hand, bias is like intercept added in the linear equation. So linear equation, all of you would have known, right? There are how it is that intercept is added and all. So now same thing, the bias is like that. So it is an additional parameter in the neural network which is used to adjust the output along with the weighted sum of the inputs of the neurons. So now it's just adjusting the weighted sum of the neurons is same. This is a weighted sum. Weight into input plus weight 2 into input 2. Here I have 2. So here they have taken 2. So now if I have so many weights, then there will be so many weights. All that weighted sum will be added with the bias. Okay, so therefore bias is a constant which helps the model in a way that it can fit best for the given data. So this weights and this bias I'm adding for the effectiveness, and I wanted to have the best fit. In order to that, I am using both the weights and the bias. Here's one example for without the bias and with the bias. So now if I'm training something without the bias, so I'll be having similar kind of output. Okay, and if I'm training something with a bias, I'll be having this output. So here there's the absence of bias, model will train over point passing through origin, which is not in accordance with the real world scenario. So also with the introduction of bias, the model will become more flexible. So now here in the real world scenarios, actually here whatever we are having will be an in the output we will have a linear function. So and that is why we will be using the activation function later in order to transform to the non-linearity. Okay, so when you transform to non-linearity, we actually need the bias all and ways all these stuff. So only then we can get the proper fit. Okay, so might be little difficult to understand for some of you people who have, I mean, who is not of this background. Okay, this machine learning and all this. So but just remember this names. Okay, weights, bias, and why it is used. It's for the effectiveness. It's for the best fit. To get the best fit, we have using all this stuffs. Okay, so now these are like the parts of the neuron or artificial neuron. Okay, so the and now if you see that the like layers, okay, we are taking this neural network into three layers or the elements. Okay, so there we have the input layer, hidden layer, output layer. So the hidden layer is will be always, mostly it would be hidden. So input layer is accepts input features. Okay, so whatever the input features, right, from the all those are called as input layer. It provides information from the outside world to the network. No computation is performed at this layer. Nodes here just pass on the information on the hidden layer. It's here from the input layer, they just get the information and then they pass it to the hidden layer. So in hidden layer, nodes of this layer are not exposed to the outer world. They are the part of the abstraction provided by any neural network. Hidden layer performs all sort of computation on the features ended through the input layer and transfer the result to the output layer. Okay, so here all the computation happens over here in hidden layer. Okay, and then they transfer the output to output to the output layer. The output layer is bring the information learned by the network to the output layer. So output layer is what we want, and we will be getting the information which we desire to get through the output layer. So this is how the network will be there. Here they are having two hidden layers here in this. So actually there would be like n number of hidden layers. There will be so many number of hidden layers, and then the computation will be taking place, and then we'll be having the output. Okay, so this will be like the structure of the ANN. So now here in this ANN another, so the first we studied about the terminologies weight, bias, and everything, right? So here some other terminologies we come across is the back propagation and activation functions. Okay, these are also other main terminologies which you should know. So the back propagation. So now we know neural network has neurons that work in correspondence of weight, bias, and their respective activation function. In neural network, we would update the weights and bias of the neurons on the basis of the error at the output. This process is known as back propagation. So here we will be updating the weights and biases of the neuron on the basis of the error at the output. So you people would have learned about the feedback system, right? So from the output you get the feedback and all. Anybody knows about it? Okay, so if you don't know, just don't confuse it. So we would be, so when we had this linear regression and all, we compared with like we had some output, we got it, and then we had the in the training we got some actual outputs, and then we compared with right. So now here when we comparing, if you take the difference of those both, the actual intended output and the output we got, if we take the difference between those both, that we call it as error. So now that basis on the error of the output, these weights and the biases people update, okay, in the neural network. So you will be having an output, you will be getting an output, and there will be an actual output which we intend to get. So comparing those both, or the difference between those both, is called the error. So on the basis of the error, they will be updating this weights and the biases. So that is why this is called as back propagation. So in some places they will be giving it as back propagation neural network. So meaning both are same. Okay. Now next is activation functions. Activation functions make the back propagation possible since the gradients are supplied along with the error to update the weights and biases. So activation function, in like, to tell it is like so we studied about the feature scaling and all those things, right? So the standardization and also, why did we study all those things? Because the data limits will be huge. Okay, so it will be like varying from infinity to infinity, minus infinity to infinity, like that. So we wanted to have a standardization. Okay, so that is why we introduced all those things. So we had it like -1 to 1 or 0 to 1. Okay, all those things in the supervised learning and supervised learning and all, we did all those things. Okay, the same thing only here the activation function will do. Okay, so now here the activation functions are mathematical equations that determine the output of the neural network model. Activation functions also have major effect on the neural network's ability to converge and the convergence speed in this in some cases. Activation functions might prevent neural networks from converging in the first place. Activation function also helps to normalize the output of any input in the range between 1 to -1 or 0 to 1. Though the it is used for the, I mean, it is the thing which is like for the computation, everything, it, the convergence point, convergence is like all the input converging to the point, all this thing with the activation function takes care of. And the main purpose of the activation function is the range. Okay, the and it is like from the linearity it transforms to the non-linearity. Okay, that is the main purpose of the activation function. The activation function must be efficient and it should reduce the computation time because the neural network sometimes trained on millions of data points. So here we are doing this so that the computation time would be lesser. So from the activation function, because what we are doing is this happens in one place, and from the activation function you get the output. Okay, that why your output will be equal to the activation function multiplied with whatever output previously got, and this thing you're going to send it to another neuron, right? So that you have to get it in the range of 1 to -1 or 0 to 1. Okay, only then the computation time will be reduced. If you have sent it like a huge thing, like so much, if it is like the data will be whatever output you are getting like minus infinity to infinity, then it will take so much a computational time, right? The speed won't be there. Okay, so that is why we are reducing it to 1 to -1 or 0 to 1. Okay, so this we will be sending to the uh, next neuron or whatever it is, the other part of this. Okay, so here like this is how it will be. So you will be having the inputs, and you will be having the weights, and here they have multiplied with the weights, and there's all the summation. So here, I mean, most of the cases the bias, they are not using it, but here all the bias will be there. Okay, remember the bias also is a main factor over here. And this all this they sum, and then they give an activation function. So here usually many of the cases, like in the starting, will be mainly learning about the sigmoid function. So any of you learn, I mean, remember where did we learn the sigmoid function before? Do you remember this diagram, this graph anywhere? Did you hear about the sigmoid anywhere? Anybody remember? Anyone remember this kind of thing, sigmoid? Is there anyone who remembers yet? I remember taking that. And those of you joining them now, please wait. I mean, like, let me, I mean, while ending, I'll just take the screenshot. After that, you can leave. So, anyone remember the sigmoid? No one remembers it. I guess nobody is. I mean, most of you. I mean, I guess from the machine learning background and also. I mean, few people I talked with, and then you people have told me that you are studying in your college all these things. So you'd be actually knowing, right? What is this? Okay, fine. The sigmoid we studied in the logistic regression. So in the logistic function, we had what we use the logistic regression. We had the sigmoid thing. Okay, with this sigmoid we classified. Okay, we classified. So this is like when the linear regression, we had a linear line, straight line, and we classified like this with the sorry, we had a straight line, and we predicted with the intercepts of all those things. With the y is equal to mx plus c, we predict. And in the logistic regression, we have the sigmoid, okay, sigmoid graph, and we will be classifying. Here the some set of data will be there, and then here on some set of data will be there. We are classifying it. Okay, so that this sigmoid function helps us to classify. Okay, when you classify, you will be having this kind of graph system. That is how we will be classifying. Okay, so for logistic regression, we use the sigmoid function. So here also you will be using the sigmoid function. Not only sigmoid function, there are so many functions are there, so many activation functions are there, but usually like they take the sigmoid function because you have already used in large regression and all. So it is like familiar thing. So usually in all the things they will first taking the sigmoid, but then there are so many activation functions available. So when you are working with a real world system, you will be using the activation function according to the purpose, which I mean, which should give the result properly. So that is how you will be using. So when I mean, this activation is mainly the range, right? So you want to have the output. You want to have the output as -1 to 1 or 0 to 1 or whatever it is. So how you want the output, depending upon that, you will select a activation function and you will apply. Okay, so here now here when I have by y, so after this y is this sum, if I have the y, if I without the sigmoid function, if I have the y, I'll be having summation of weights into inputs plus bias. Okay, so here this range is from minus infinity to infinity. Okay, so now that is why I have to include my activation function. So now what I will do is this activation function I will multiply with my uh, this summation, with this summation of my weights into inputs plus bias. Now here it's a bias is not given, the bias will be there. Okay, so now here the bias also will be there, and then this multiplied with the activation function, I'll transform whatever I think from minus infinity to infinity. I have got it right, so I'll be transformed to 0 to 1 or -1 to 1. Accordingly, I will use the an activation function and I'll transfer it. So the activation function is an important part of an artificial neural network. They decide whether a neuron should be activated or not, and it is non-linear transformation that can be done on the input before sending to the next layer of neurons or finalizing the output. So after the activation function only, we will be sending to the next layer of neurons. So here this will be connected with the set of neurons. Okay, so many neurons will be there, it will be connected to it. So before finalizing the output, this should be done. Okay, we are what we are doing is like kind of like what we studied, the standardization and what we studied, and kind of that only we are doing it. Okay, so that is necessary for the computational speed, all these things. Okay, so now here, the most commonly used or the most familiar activation function would be the sigmoid or logistic function. This you have already seen in the logistic regression. So the sigmoid function is a logistic function and the output is ranging from 0 to 1. If you want the output to 0 to 1, then you will be using the sigmoid. Okay. So now here, this is a formula for sigmoid and your graph will be like this. Okay, when you are using the sigmoid function, okay, you'll be having the values like this. And here this center won't be zero. Here it won't be a zero centered thing. Okay, so here the output of the activation function is always going to be in range 0 and 1. So here whatever it is below 0.5, I'll take it as in the range of 0, and whatever it is above, it will be like in the range of 1. Okay, that is why I won't be having here, there is a sender 0. You are getting my point is right. So if minus 1 and 1 means I may have here the center as 0. But here I can't have it because we are having the range as 0 and 1. So the output of the activation function is always going to be in range 0, comma 1 compared to minus infinity of linear function. It is non-linear, continuously differentiable, monotonic, and has a fixed output range, but it is not zero centered. Okay, this is a non-linear thing. So actually whatever output we are getting over here is linear. This is a linear thing. Why we are saying it as linear? Because it is same as y is equal to mx plus c. The same linear line equation we will be getting. So now here this activation function will be adding and it will become a non-linear thing. So now when there is an exponential coming up, and it will be always a non-linear function. So from the linear, it will be converted to non-linear, and it can be continuously differentiable. So you can differentiate. Okay, that's continuously differentiable. It's monotonic. That is similar. It will be like the similar range. It will be like and have a fixed output range, and it is not zero centered. These are some of the properties of the sigmoid function, and you have so many functions, remember that, and according to that you choose a activation function. Okay, according to what you need, what the output you need, or what the output you want to send to the neurons, you will be choosing the activation function. So, so coming to the end of this, neural networks, one of the hottest machine learning and researching area today. So the neural network is like they are researching so much into this. Okay, because it's like the most needed or the most wanted thing of the hour. So all the data giants like the Google, Facebook, etc. have invested heavily in mastering and researching these algorithms. So if you are mastering in this deep learning, right? So it's like you can go into a different level. I mean, your salaries also would be very higher, and your post would be like similar to the scientist. So this deep learning is like the most needed thing of this hour. So now all data giants are actually investing a lot because they are researching so much. So because whatever we want is like from what from, because it's like all through the process. Like now when we were small, we would have had like the big desktops and everything. Now also the mobile phones we had, like without, we didn't have a smartphone. So now because of so many this artificial intelligence, because of all these systems, we are able to have the smartphone, and we have we have laptops, and we are able to do so many things parallelly. We are able to compute a lot of things, and this process will be going on. So all the things, I mean, they'll be developing so many things to be done. I'm a single system to do the so many things. So the bigger systems, they will be developing to smaller systems, and what system which would be doing one or two tasks, it should do some hundreds of tasks. This is what it will be. This process will be going on. This research will never stop, so that it will never stop, because they will never reach to the level of the human brain computation. So either research will be like lifelong, it will be, I mean, it's not lifelong means it would be like a never ending, like till earth is there, till human beings will be there, the research will be going on. So that is why this deep learning is like they invest a lot over here. Okay, so because we a lot to learn and lot to research is there. So now here then example, I already told the voice recognition problem. Okay, so here for example, the imagine I was solving voice recognition problem. All the past dialogue spoken by you become the input for the neural network. So here, I mean, we were seeing, right? So what the inputs and all those things. So all the past dialogues, what whatever I am talking, right? So all these things they'll put as an input. So now if you see some of the advertisements and all for the career, I mean, if any of you are checking like the career, if you are in the final year or something, if you are checking for the career and all, so there will be like in Facebook and all, so many advertisement will be coming, like we have to speak and send. So for that they will be giving us salaries. Okay, so why we they are asking us to speak and send is they need so much of data. Okay, so so much of data they need. Why they need is to train. Okay, so the train such that the thing should recognize. So now my input would be my audio. All my audio messages will be my input on neural network, and the words from the dictionary become the output. So now whatever I am talking as an audio, and the will be converted to text. Now in the YouTube and all, you can see all the text will be down. Okay, whatever it's said, the text will be down. So this is a voice recognition problem. This is like already is there, but if you see in the YouTube, there will be a lot of mistakes would be there. Okay, so still rectification is needed. So by training a huge number of inputs from several people, can we create a neural net which is able to predict the right words as output? So answer is a subject matter, some of the best researchers across the globe. This subject is now popularly being called as deep learning. So now this thing is the properly known as the deep learning, and which is in huge demand now. Okay, so because the research will never end. So this is the basis of the neural network. So I mean, hope you people got I mean little idea about the neural network. Those of you are not from the machine learning background, oh, you people would have got the basic of this, I guess, right? So once again, I'll just briefly tell. So this neural networks is ANS, nothing but similar to the human brain. So as we have in the human brain the neurons, like we have the dendrites, and from that the information go to the cell body, and then the axon will carry the information, and then through the synapses it connects to the other neurons. That's other neurons, in the sense other dendrites will be connected, and then again the cell body will be there, again the axon will be there, and like that the connections will be going on. Okay, and then it will process all the information to do something. Okay, whatever I have to do, I'll be doing. So I'll be doing lot of works parallelly. I'll be now I'm teaching, as well as I'll be checking whether any messages there, all these things. So all these things I'll do parallelly. So that is the main thing they are aiming to be here. So here soma in the neural network, I mean biologic neural network, will be called as node, and the dendrites will be like an input, and synapse will be like the weights or interconnections, and axon will be the output. And so this is how the, I mean, the artificial neural networks looks like. And here inputs will be having, weights will be having, and also the bias will be there. And then all the summation will be taken and given an activation function. And then we'll be getting the output. So we have this weights and bias in order to have an effectiveness of the particular input, and also to fit the best. I mean, the model should have a best fit. So in order to that, for all these things, we are having the weights and the bias. So and then when you that elements you have, as you see, or the layers as you see, there will be like input layer, hidden layer, and output layer. So the hidden layer is where like the soma is there, so we won't be seeing anything that is like inside your head. So the inputs will be we will be perceiving some information, and in the hidden layer of the head something happens, and then the output we will do something. So similarly here also you will be having in the input layer, and the hidden layers all the information will be processed, and whatever have to be done will be done, and then you will be getting the output. And then this back propagation in this neural network, what the weights and biases will be updated on the basis of the error at the output. Error is nothing but the difference between the output you intended with the output you got. So that is like a feedback system it is. So that is called as a back propagation. And this activation function we are using mainly to take the linear function, the transforming the linear function to the non-linear function, where we have a fixed range of like 1 to -1, or -1 to 1, or like 0 to 1, or however it is you want. So depending upon how you want the output, you will be defining the activation functions. So, and then this most of the time in the neural and the sigmoid activation function will be used. Sigmoid is same as the logistic, and here the sigmoid will be non-centered, and also the sorry, not zero centered, and also you'll be having a range of 0 to 1. Okay, so that is how it is. And this deep learning is the main talk or the main need of the hour. So I mean, it's good to get a career over here. Okay, that's so for today. Just wait for taking this attendance. Wait a second, I'll just take the screenshot. And anyone wants to know anything? Okay. Okay, I've taken the attendance. So I'll be sending, I'll discuss the sir, and then I'll be sending the project, what you have to do by today, okay? So, so anything else, if you don't want to ask anything, you can leave.
Thank you, ma'am.
Thank you, ma'am.
Okay, thank you all.